We are going to do a short factoring review, and then we're going to move on to operations with polynomials and exponent rules. So we're going to start out with some factoring review. This is all stuff that we already learned, but we're going to do some of this stuff again, so we need to review it. It'll also help you with things like the TSI test, because this stuff is factoring is asked a lot on TSI. So the first question, it's a GCF question. You look at both terms and you want to find the greatest common factor. And you can look at both terms. You can look at the numbers and the variables. So what's the biggest number that I can divide out of 54 and 2? 2. So I'm going to pull out a 2. Do both terms have an A? Yeah. What's the most amount that I can pull out? 2 of them. And do both terms have a B? No, so I can't pull a B out. Hello. From here, I'm going to pull out the 2a squared, and then I'm going to write down what I have left. If I divide 54 divided by 2, what do I get? 27. And then anytime that I have a, you're fine, I just can't see. Anytime you have an A on top and an A on bottom, when you're dividing, you subtract. And so I have 5 on top, 2 on bottom. So I have 5 minus 2. So I'll have A to the 3rd power. 2 divided by 2 is 1. Anything divided by itself is 1. So I don't have to write any A's. And then I just have B to the 3rd power. Do I have to have the 1 right here? No, I don't have to have it. I could erase that one. It's not wrong if I have it, and it's not wrong if I don't. Next type of factoring, we've got difference of perfect squares. Anytime you have something squared minus something squared, you can do the difference of perfect squares. And for this one, I'm going to start by rewriting it. This is the same thing as x squared minus 4 squared. Do you agree? Yeah. So now I can use this formula. Anytime I have something squared minus something squared, so now they're both squared, I'm going to set it up like this. I've got 2 parentheses. It's still set equal to 0. And I put the first thing first, the second thing second, and then one of these has to be plus and one has to be minus. It doesn't matter which one. You just need 1 plus 1 minus. Anytime you are set equal to 0, you can actually solve this and get a solution set. So for this one, x is equal to, and I get my solution set by setting each one of these equal to 0. So I could solve them by setting each one of these equal to 0, x plus 4 equals 0, and then x minus 4 equals 0. These are really easy. We can do them in our head. So what are my 2 solutions? Negative 4 and 4. Next type of factoring. Anytime you have 3 terms, you always want to check and see if there's a GCF. Derek, are you with us? So is there a number that can divide into all 3 of these? I think I heard it, but my keys were rattling. 2. Yes. So let's divide everything by 2 first. it will make our problem way easier. So if I divide by 2, 2 comes out first, and I get x squared minus 8x plus 15 equals 0. From here, we are fast factoring. So if you remember, when you fast factor, you look at factors of 15. And I just run down the list starting with 1. I have 1 and 15, 2 and not 2. Not 2. Why did I put 2? 2 is not a factor. 3 and 5. Any others? So fast factoring says that I find the pair over here. Which one of these pairs can I put together in such a way to make 8? 5 and 3. So I'm going to put these in. I know I have to have x and x. That's the only way I can multiply to get x squared. And then I'm going to put 3 and 5 in. It doesn't really matter which one you put them in which set of parentheses. Just put one in. I tend to have the smaller one on the left side, but it doesn't matter. From here, I have to look at my middle term. My middle term is negative, and that will always determine the bigger number. So the bigger number will be negative. And then from here, if I have negative 5, would I add or subtract 3 to make negative 8? Subtract. That's why they're both negative. Since this is equal to 0, I can also get a solution set. Is there an x out here in front? No, so I don't have to look at that. I only have to look at where I have an x. So I want x equals. So if there's no x in front, the 2 doesn't tell me anything. Here, what does x equal? Here, what does x equal? 5. So my solution set is 3 and 5. Does it matter which order those are in? Not really. We tend to write them in numerical order, but it's not wrong otherwise. The next one, is there a GCF? Can I divide anything out? Is there a GCF? Like here, our method of attack was that we found a GCF, we divided it out, and then it was fast factoring. Can we do that here? Yeah, 1 is the only thing, so that doesn't help us. So when that happens, we have to split the middle. When we split the middle, this is something we have to kind of remember. We have to multiply A times C. So 2 times negative 12 will give us negative 24. And we have to look at factors of negative 24. So at the moment, I'm going to ignore the negative. And I'm just going to find factors. So 1 and 24. We've got 2 and 12. 3 and 8. 4 and 6. Can one of these pairs be put together to make 5? 8 and 3. So if we put them together to make negative 5, I would have to have the bigger number would have to be negative, and then I would have to add 3, right? Negative 8 plus 3 will give me negative 5. So I'm going to rewrite negative 5 as positive 3x minus 8x, bless you. And then I'm going to rewrite the 2x and the 2x squared and the minus 12 on each side. So this is called splitting the middle. From here, I'm going to factor by grouping. If you get a problem and it already has 4 terms, you go straight into factor by grouping. In fact, if you look at your homework, I'm pretty sure you have some that are already 4 terms. Question number 3, already 4 terms. That's how you will factor it. You're going to factor by grouping. So factor by grouping says that we've got groups. And then for each group, you're going to find the GCF. So what's the biggest number I can pull out of 2 and 3? Do they have something in common? Yeah, they don't have anything in common but one. But they do both have an x, so I can pull out an x. So out in the front, I will get an x, and then I will be left with 2x plus 3. Remember, our goal is to get two sets of parentheses that are identical. My next GCF, I notice these are both negative, but I need them both to be positive, so I'm going to definitely have to pull out a negative. I think there might be something bigger that can go into 8 and 12. Nothing bigger. 4 is good. I don't know why I said that. 4. And I can't pull out an x because they don't both have an x. So out into the front, I have minus 4. And then negative 8 divided by negative 4. So close. 2x, you're just ahead of me. And then I get plus 3. Very good. Now I have another GCF. When you have two parentheses that are identical, it's a new GCF, 2x plus 3. So I can rewrite this. And I get 2x plus 3. And then x minus 4. That comes from what is left. Another way to think about how you get this line is from both of the things that are written in pink. So you get x minus 4 and 2x plus 3. From here, they're set equal to 0, so I can definitely get a solution set. So x equals, and you may or may not have to write these out. This one's easy. What's this one going to be?
4.
4. Okay, for the other one, well, we know if that's negative 4, it becomes positive 4. Well, if this one's positive 3, it's going to be a negative 3. Then the only thing you have to do is divide by 2. So again, you can always start with this part. You always start with this part, and then you divide by the other number. And since it can't be reduced, we're done. If you struggle with any of these types of factoring, I just recorded this lesson. You should go back and you should rewatch it. There's also videos from first semester where I go through each type of factoring in one day. And so you get a lot of examples. If you struggle with factoring, you got to brush up on those skills. It's not going away. When you leave Algebra 2, if you can do one thing, it better be factoring. You better know how to factor. We're going to do our brain break at the very end since I'm recording this one. Next, we're going to go to exponent rules. Exposed to before, but we're going to review them. First, anything to the 0 power. Well, does anybody know that? Anything to the 0 power? Y'all have your phones, so go to the calculator on your phone. One off would still be wrong on a multiple choice question. Yes, anything to the 0 power is 1. That's also our essential question today. What does anything to the 0 power equal? Don't waste your time. Like, you got to commit that to memory. Anything to the 0 power is 1. So what's 14 to the 0 power? 1. Well, what about negative 5 to the 0 power? 1. What about 152.3 to the 0 power? 1. It doesn't matter what it is. It's 1. Anything to the 0 power is 1. Negative exponents. These might be new. So exponents are not new. We've been working with them. In fact, let's come down here. Let's skip this one and we're going to come back to it because this might be new. When the coefficient, so the coefficient, that's just the number in front. A coefficient is just the number in front. When the numbers in front, so you've got 4 minus 2, when the numbers in front are adding or subtracting, the exponents don't do anything. They stay the same. So when these exponents are the same, and you can only do this if they're the same, you have 4x squares, and then you want to take away 2x squares. Well, you still have x squares. But if you have 4 and then you take away 2, you only have 2 of them. So the exponent stays the same. It doesn't change. So it doesn't work if you have x to the third power and x squared. It can't stay the same because they're not the same. You can't add or subtract them. When you multiply, the exponents add. That's interesting, but that's what happens. So an example, what happens to the numbers or the coefficients is that you're multiplying them. What's 5 times -3? -15. So the coefficients, the numbers in front, they multiply, but the exponents, I have x's, and it only works if they're both x's. You can't do this with an x and a y, but you will add them, and you're right. 3 and 2 makes 5. When you are dividing, when you multiply, you add. So if you divide, what do you think you do? Subtract. We've already done this on examples. Like when you divide by the GCF, you are subtracting. But one thing I want to stress to you is that you subtract to the bigger one, and I'll explain why. That will help you avoid negative exponents. You don't want negative exponents. So it's not like you always subtract to the top, which is often what we're doing when we do a GCF. It always subtracts to the top. But now you could subtract to the bottom or the top. It just depends. You want to subtract to the bigger one. So this is dividing coefficients. So 4 divided by 2, that doesn't change. What is 4 divided by 2? Yeah, 2. Okay, we get 2. And then I notice I have x's on the top and the bottom. I have 2 on top, 3 on bottom. Well, which one's bigger? No, I have 2 on top, 3 on bottom. So I've got more on bottom. So what I'm going to do is I'm not going to bring it up to the top because then I would get a negative exponent. What's 2 minus 3? Negative. We don't want to do that. So we're going to take it out of the top and we'll subtract 2 on bottom. So we'll end up with 2 divided by, what's 3 minus 2?
1.
1. So we'll end up with 2 divided by x. Do I have to put to the first power? No. For the next one, well, what's 3 over 6? Because that's dividing. 1/2. So we get 1/2. And then let's look at the exponents. On top, I have 5. On bottom, I have 3. Which one's bigger? 5. So I'm going to subtract 3 on the top, and I get x. How many of them? 2. When a coefficient or the number in front is raised to a power, the exponents are going to multiply. So what happens here is that this 2 on the outside distributes to everything inside. So it's going to go to the 5 and it's going to go to the 3. So I'm going to do it slowly. I'm going to rewrite it. So I get 5 squared and then x. What's 3 times 2? 6. What's 5 squared or 5 times 5? The exponent tells you how many times you write it. 25. 25x to the 6th power. So far, everything that we've done, all of our answers have had positive exponents. That's not always the case. Not always do you have a positive exponent. So we need to know what to do when they're not positive. So we're going to jump back to negative exponents. And the first one, if you have a negative exponent, you rewrite it as you change spaces. So right now it's written as a numerator. I'm going to rewrite it as a denominator. So the 2 doesn't have a negative exponent, so I leave it alone. So I end up with 2. And then the x has a negative exponent, so I'm going to rewrite the x in the denominator, and then it becomes a positive exponent. Yep. Here, you have a negative exponent and it's in the denominator. So now we're going to rewrite it as a numerator. So now we just put it in the top. The 1 doesn't have a negative exponent. The 2 doesn't have a negative exponent. We leave those. So you're still going to have 1 over 2. The only difference is I'm going to rewrite the x to the negative third power. It's going to go to the top, and I'm going to say to the third power. And now it's positive. Yes, that's why we're doing it. Another situation is that you have stuff in parentheses and it's all raised to a negative exponent. So what you can do if you have something in parentheses and it's all raised to a negative exponent, you just take that fraction and you make the reciprocal. You just flip it upside down. So x over 1. So we get x over 1, and then it becomes to a positive exponent. Do I have to write divided by 1?
Wait, so like we just flip the thing, we don't change the.
No, because technically what you're doing, if you just distribute this into both pieces, that says I have to rewrite the 1 in the denominator. That would say I have to rewrite the x as a numerator. So you can just flip it. And that's going to be the same thing as just x squared, because I don't have to write divided by 1. So this is a whole lot of notes on exponent rules. And now on the back, we're going to practice. We've got a lot of, some of these things you've already done, you've been doing, and some of these things are new and you have very little experience with them. So we're going to practice these skills, and then you'll do your homework and practice it some more. Doesn't that sound like a fun first day back? Oh. Again, we'll take our break when we're done so that my video doesn't cut off. So the first thing that we're going to do, oops, I have a negative exponent. That's not good. So this is the same thing as 5 divided by 1. I'm going to rewrite that as a denominator. So I have 1 divided by 5. Now it can be a positive exponent. So I have to rewrite it as a denominator. And what's 5 squared? 25. So this is the same thing as over 25. And that's just how we fix a negative exponent. While we're talking about negative exponents, do you see any other negative exponents? And this one is where you have a fraction in parentheses. So what can we do if we have a fraction in parentheses? It was the last property that we just wrote down from the front. If you have a fraction in parentheses and it has a negative exponent, what do we do? Flip it. So I'm doing D now. So D would turn it, it's still negative, but it's going to change to 3 over 1. And now it has a positive exponent. So I can change it to a positive exponent. And then I get this. Do I have to write over 1? What's 3 divided by 1?
3.
There's 3. So we can ignore the divided by 1. But for this, I would have to distribute in the 2. And when I have something raised to an exponent, so this is like negative 3 times negative 3. What's negative 3 times negative 3? What's a negative times a negative?
Positive.
What's 3 times 3?
3 times 3?
Yep. 9.
Wait, why is it? Oh, it's because
It says I have two negative threes. So negative 3 times negative 3 gives me positive 9. Here, there's nothing tricky about that. It says that I have 3 times 3 times 3 times 3. I have 4 threes. That's what that says. And believe it or not, this is something we're capable of doing in our super brains. What's 3 times 3? We just did it. 9. And so it's 9 right there. What's 9 times 9?
times 9, 81.
81. You are capable. You are smart. The next one. It's not a negative exponent. It's a negative number to a positive exponent. So I don't have to do anything with the exponents. It's fine. So from here, I have negative 4 3 times negative 4 times negative 4. Well, let's do it bit by bit. What's negative 4 times negative 4? Positive 16. So then I have positive 16 times negative 4. So times negative 4. I can do this. I don't need a calculator. What's 4 times 6? 4. And I add the 2. 4 times 1 is 4. I add 2, so I get 6. And a negative times a positive will be a negative 64. When you are doing your homework, I expect to see work. Some of these things like 5A through D, all of those you could have typed into your calculator and gotten an answer. You're not going to get credit for that on your homework. I want to see your work. Like you've got to learn these properties. So if you turn it in with just answers, you're not going to get credit. Next, we're going to simplify and we're going to write without any grouping symbols or negative exponents. Grouping symbols are parentheses, no more parentheses. So when I look at this, I have 3x minus 5x squared, and I'm adding it to 6x minus 8 plus 2x squared. All we're doing here is combining like terms. And I don't need to do anything when I have a plus in the middle. So all I have to do is combine like terms. I've got 1x term here, and I have 1x term here. So I can combine them. So I'm going to combine like terms by finding like ones. So these are alike. I have an x squared term here. Do I have another one? Yeah, so we can combine these. And then I just have one lone 8. So I've got 3 different terms. When we write in standard form, you start with the biggest exponent. So when I'm looking at these, I have something with no exponent, something to the first power exponent, and something to the second power. So I start with the biggest one. So I'm going to start with the x squared terms. So I have minus 5 plus 2. What does that give me? So minus 5 plus 2. Negative 3 x squared. So when the coefficients, when you're adding or subtracting them, the exponents stay the same. When they are the same, they stay the same. So I just took care of those. I'm going to mark them off so I make sure that I count each one. Now I have 3 plus 6 plus 9x. So I just took care of those. And then I have a minus 8 that's all by itself. There's nothing to combine. So this is just combining like terms. Some of these properties should seem familiar because they're not really new. You've been combining like terms. For B, the only thing different here is that you've got a negative out in front. So you have to distribute the negative to each one of the terms, which just means that the sign changes. So this says opposite of positive 5, opposite of positive 3, opposite of positive 6. So if it's a positive, it changes to a negative. If it's a negative, it changes to a positive. So it's just opposite sign for all of those. So I have to distribute that in, and I'm going to rewrite it because I don't want to make a mistake. So I'm rewriting the second set of parentheses. So I get minus 5 minus 3x minus 6y to the third power. I didn't do anything to this, so I can just write it the exact same way that it is. 6y to the third plus 2x. Now I'm going to find like terms. So do I have any other y to the thirds?
Yes.
Yes. So I'm going to combine these. Do I have any other x's?
Yes.
Yeah. And it looks like I just have one constant by itself. So I'm going to do the same thing I did with the first one. I'm going to combine terms. What's 6 minus 6? None. So none. What if I have 2 minus 3? Negative 1. Do I have to write the 1? Nah, negative x will work. And then I have a minus 5. That's it. We're going to take our break as soon as we're done, but I'm going to take a deep breath because I've been talking a lot. Negative x minus 5. Do you want to take the pass just so you don't get stopped? All right. Now we're going to get a little bit more complicated. When I look through, so this is multiplying. So I'm going to multiply. What's 3 times negative 4? Yep. Negative 12. So when I multiply coefficients, what do I do to the exponents? Add them. Very good. So I have 7 plus 2. Yep. And that's it. I'm going to skip over to this one. For this one, I'm dividing. What do you do when you divide? What do you do with the exponents? Subtract. But I'm going to subtract to the bigger one. So when I look, I've got, for the y's, 2 on top, 1 on bottom. Which one's bigger? Yep. So I'm going to subtract 2, not 2, subtract 1. 1. Subtract 1. And then for the z's, I've got 5 on bottom. That's bigger. So I'm going to subtract 3 minus 3. And I'm going to rewrite this. So on the top, I have y and I have 2 minus 1. So I just have 1. Do I have to write the 1? No. In the denominator, I'm going to end up with the z's. And I have 5 minus 3. 2. When you multiply, you add exponents. When you divide, you subtract. So now we're going to do a little bit more steps. We're going to distribute in. So anytime you distribute to everything. Everything. So I try not to forget that by actually drawing little arrows in so that I don't forget. I'm going to distribute into everything. And then rewrite. So I get negative 5 to the third power. When I have a power to a power, what am I doing with these? Nope, you add when you multiply. Multiply. Yep. So 3 times 3 is 9. And then I have negative 3 times 3. Negative 9. For the z's, I have 2 times 3, 6. I still need to evaluate this piece right here, and I can't have a negative exponent. So for this part, I could do it off to the side to do, so it's -5 times -5 times -5. You've got 3 -5s. Well, what's -5 times -5?
25.
Positive 25, yep. And then I'm going to have to multiply these two. So negative times a positive, my answer is going to be negative. 25 times 5. Let's think about 5 quarters. If you have 5 quarters, how much do you have? 125. You can do this. You can do big math. Okay, so we did that part. So we've got -125. There's nothing wrong with x to the 9th power. What about y to the -9th? How do I fix it? How do I fix a negative exponent? I change it to a positive, but the only way I can do that is to write it down here. I have to move it. And there's nothing wrong with z to the 6th. You only have to rewrite stuff if it has a negative exponent.
So if it's a negative, we put it on the bottom.
Oh, yeah. Or if it was in the bottom, you put it in the top.
Oh, and then just.
Yeah. So the next problem, you've got choices. You can either distribute in the 2 and then simplify it. But I think it's a little easier if you simplify first and then distribute in the 2. So to simplify first, what is 6/4? That's going to reduce. Aren't they both divisible by 2?
Yeah.
Yeah, so that'll change to a 3, and the 4 changes to a what? 2. All right. Now let's look at M. I have 7 on top, 1 on bottom. What do I do? Yep, subtract 1 from 7. And then for the ends, I have 3 on top, 5 on bottom. I'm going to subtract 3 on the bottom. So I'm going to rewrite this stuff in parentheses, and it stays in parentheses. So I have 3/2. Staying in the top is the M. 7 minus 1 is 6. The ends will stay in the bottom. 5 minus 3 is 2. Any questions over just simplifying the inside of my parentheses? All right, from here, all I have to do is distribute in the 2 to everything in the parentheses. So it has to go to everything on the top and everything in the bottom. You got to put it to everything. When I rewrite it, I'm going to kind of do some of this stuff in my head. What is 3 to the 2nd power? What? What's 3 times 3? 9. M to the, what's 6 times 2? Yep. 12. What's 2 to the 2nd power? 4. And what's 2 times 2? 4. I'm going to double check to see if anything can reduce. 9 divided by 4, can that reduce? No. I don't have any other M's. I don't have any other N's. I am simplified. Again, you could have distributed in the 2 to everything, but you just would have had more pieces. You would have had 2 extra pieces, and you would have had to simplify in the end. So I think it's a little easier like that. We're almost done. Take a deep breath. We only have 1 more slide, 2 more problems. We can do this. I know it's our first day back, but we're doing awesome. Which one looks really scary? A looks scary, right? Because there's a lot of stuff going on. It's not. Okay, trust me, it's not bad at all. What you have to do is you have to rewrite it. When you rewrite it, I'm going to rewrite it with the numerator for however many pieces are there, however many terms. So I probably should have this a little bigger. Let's make it a little bigger. Okay. So when I'm looking at this, do you see how there is 1, 2, 3 terms? Because we're only adding or subtracting twice. So I have 3 terms. So 1, 2, 3 terms. Does everybody see that there are 3 terms? So I'm going to rewrite just the numerator. Okay, I'm rewriting just the numerator. So I have 24 x squared y to the third minus 32 x to the fifth y to the sixth plus 16 x squared y to the fifth. All I did was rewrite the top. And all I do now is that I'm going to split this, the denominator. I'm going to split it up and I'm going to put it over each one. So I'm going to say divided by, divided by, divided by. It's all the same denominator. I'm just splitting the fraction. So the main thing that you do for this type of problem is just rewrite. Okay, once you rewrite it, all you're doing is reducing each one of those fractions. So looking at my first fraction, can 24 over 8, can that reduce? Yeah, 24 divided by 8, so this will turn into a 3. I have x squared divided by x squared. What's anything over itself? 1, so these cancel out. And then I have 3 on top, 2 on bottom. Which one's bigger? Yeah, so I'm going to take them out of the bottom and subtract 2. So I can rewrite my very first term. It looks like I'm going to be left with no denominator. Nothing is going to stay down here. So I'm going to have 3y to the first power. Yeah, so it's just 3y. Do I have to write to the first power? No. All right, next. It's a negative right there, so it's going to stay negative. Now I can look at the numbers. 32 over 8, how does that reduce? Yep. 8 goes into 32 4 times. And then when I look at the x's, I have 5 and 2. Yep, so I will subtract 2. What about the y's? Top one's bigger, so I subtract 2. Looks like, again, I'm going to have nothing in the denominator, so I will be left with 4 x to the 5, 4, 3, x to the third, and then y to the fourth.
Wait, but it's
And it keeps the negative. Here, it's a positive, so it's going to stay positive. 16 over 8, 2. My x's, what's anything over itself?
1.
1. 5 and 2. Yep, I will subtract 2. So what I'm left with is 2y to the third power. So this is one of those examples of a problem that looks scary, but it's not that bad, really. It looks ugly, but it's not that bad. Last problem. I am going to do this with a box. You could also use foil, but I'm going to use a box. I think you'll make less mistakes with a box. So I'm going to get a box. The only thing that's going to be different about my box is that this time I need 3 columns because I have 3 things here. But I only have 2 here, so I'm just going to have 2 rows. So I'm going to have x minus 4, and then x squared plus 3x plus 5. The skills that we use in here are no different than any other time you've ever used a box. Like you didn't realize you were using exponent rules, but you were. So here, this is like 1 times 1 is 1. And then I have an x. I have 2 and 1, so now I have 3. So the third power. You can fill this in whatever order that you want. 1 times 3 is 3, so plus 3. What's x times x? X squared, yep. 5 times x is 5x. I'm going to fill in the bottom row. I want you to see if you can fill in the bottom row. Look up if you get stuck, but I'd like for you to try it. Did y'all get the same thing as me? All right, from here, I'm going to combine like terms. When I combine like terms, usually they combine diagonally. That's what's really nice about using the box is it cleans it up for you. So I only have one term that's x to the third, but looky, there are 2x squared terms and there are 2x terms. So I will combine anything that is the same. Again, they typically combine diagonally. And there's nothing to combine with the first or the last term. So I'm going to rewrite this. This equals x to the third. Next, I have x squared. Well, what's 3 minus 4? Negative 1x squared. Do I have to write the 1? No. Is it wrong if I do? No. So put it or don't put it. It's no difference. And then I have negative 12 plus 5 or 5 minus 12. Negative 7x and then minus 20. Use a box for these. You can distribute, but you're way less likely to make mistakes. And that is our notes for today.